directed energy weapons microwave blasters that fry drones mid-AI. Imagine, China deploys hundreds of thousands of autonomous drones in the air, on the sea, and under the water, all armed with explosive warheads or small missiles. These machines descend in a swarm toward military installations on Taiwan and nearby US bases, and over the course of a few hours, a single robotic blitzkrieg overwhelms the US Pacific Force before it can even begin to fight back. Maybe it sounds like a new Michael Bay movie, but it's the scenario that keeps the Chief Technology Officer of the US Army up at night. I'm hesitant to say it out loud so I don't manifest it, says Alex Miller, a longtime Army intelligence official who became the CTO to the Army's Chief of Staff in 2023. Even if World War III doesn't break out in the South China Sea, every US military installation around the world is vulnerable to the same tactics, as are the militaries of every other country around the world. The proliferation of cheap drones means just about any group with the wherewithal to assemble and launch a swarm could wreak havoc. No expensive jets or massive missile installations required. Related story. Meet the radio-obsessed civilian shaping Ukraine's drone defense. Since Russia's invasion, Sergei Flash Biskresnov has become an influential, if sometimes controversial, force, sharing expert advice and intel on the ever-evolving technology that's taken over the skies. His work may determine the future of Ukraine and wars far beyond it. While the US has precision missiles that can shoot these drones down, they don't always succeed. A drone attack killed 3 US soldiers and injured dozens more at a base in the Jordanian desert last year. And each American missile costs orders of magnitude more than its targets, which limits their supply. Countering $1,000 drones with missiles that cost hundreds of thousands, or even millions of dollars per shot can only work for so long, even with a defense budget that could reach $1 trillion next year. The US Armed Forces are now hunting for a solution, and they want it fast. Every branch of the service and a host of defense tech startups are testing out new weapons that promise to disable drones en masse. There are drones that slam into other drones like battering rams, drones that shoot out nets to ensnare quadcopter propellers, precision-guided Gatling guns that simply shoot drones out of the sky, electronic approaches like GPS jammers and direct hacking tools, and lasers that melt holes clear through a target side. Then there are the microwaves, high-powered electronic devices that push out kilowatts of power to zap the circuits of a drone as if it were the tinfoil you forgot to take off your leftovers when you heated them up. That's where Epirus comes in. When I went to visit the HQ of this 185-person startup in Torrance, California, earlier this year, I got a behind-the-scenes look at its massive microwave, called Leonidas, which the US Army is already betting on as a cutting-edge anti-drone weapon. The Army awarded Epirus a $66 million contract in early 2023, topped that up with another $17 million last fall, and is currently deploying a handful of the systems for testing with US troops in the Middle East and the Pacific. The Army won't get into specifics on the location of the weapons in the Middle East but published a report of a live-fire test in the Philippines in early May. Up close, the Leonidas that Epirus built for the Army looks like a 2-foot-thick slab of metal the size of a garage door stuck on a swivel mount. Pop the back cover, and you can see that the slab is filled with dozens of individual microwave amplifier units in a grid. Each is about the size of a safe deposit box and built around a chip made of gallium nitride, a semiconductor that can survive much higher voltages and temperatures than the typical silicon. Leonidas sits on top of a trailer that a standard-issue Army truck can tow, and when it is powered on, the company's software tells the grid of amps and antennas to shape the electromagnetic waves they're blasting out with a phased array, precisely overlapping the microwave signals to mold the energy into a focused beam. Instead of needing to physically point a gun or parabolic dish at each of 1,000 incoming drones, the Leonidas can flick between them at the speed of software. Leonidas device in a warehouse with the United States flag. The Leonidas contains dozens of microwave amplifier units and can pivot to direct waves at incoming swarms of drones. Of course, this isn't magic. There are practical limits on how much damage one array can do and at what range, but the total effect could be described as an electromagnetic pulse emitter, a death ray for electronics, or a force field that could set up a protective barrier around military installations and drop drones the way a bug zapper fizzles a mob of mosquitoes. I walked through the non-classified sections of the Leonidas factory floor, where a cluster of engineers working on weaponeering, the military term for figuring out exactly how much of a weapon, be it high explosive or microwave beam, is necessary to achieve a desired effect, ran tests in a warren of smaller anechoic rooms. Inside, they shot individual microwave units at a broad range of commercial and military drones, cycling through waveforms and power levels to try to find the signal that could fry each one with maximum efficiency. On a live video feed from inside one of these foam-padded rooms, I watched a quadcopter drone spin its propellers and then, once the microwave emitter turned on, instantly stop short, first the propeller on the front left and then the rest. A drone hit with a Leonidas beam doesn't explode, it just falls. Compared with the blast of a missile or the sizzle of a laser, it doesn't look like much. But it could force enemies to come up with costlier ways of attacking that reduce the advantage of the drone swarm, and it could get around the inherent limitations of purely electronic or strictly physical defense systems. It could save lives. Epira CEO Andy Lowery, a tall guy with spark-plug energy and a rapid-fire Southern Illinois twang, doesn't shy away from talking big about his product. As he told me during my visit, Leonidas is intended to lead a last stand, like the Spartan from whom the microwave takes its name, in this case, against hordes of unmanned aerial vehicles, or UAVs. While the actual range of the Leonidas system is kept secret, Lowery says the Army is looking for a solution that can reliably stop drones within a few kilometers. He told me, they would like our system to be the owner of that final layer, to get any squeakers, any leakers, anything like that. Now that they've told the world they invented a force field, Lowery added, the focus is on manufacturing at scale, before the drone swarms really start to descend or a nation with a major military decides to launch a new war. Before, in other words, Miller's nightmare scenario becomes reality. Why zap? Miller remembers well when the danger of small weaponized drones first appeared on his radar. Reports of Islamic State fighters strapping grenades to the bottom of commercial DJI Phantom quadcopters first emerged in late 2016 during the Battle of Mosul. I went, oh, this is going to be bad, because basically it's an airborne IED at that point, he says. He's tracked the danger as it's built steadily since then, with advances in machine vision, AI coordination software, and suicide drone tactics only accelerating.